Okay, so in this part, we will talk more trig identities. So the first formula is about the double angle formula. Sine 2u, 2 times 2, so this is called double angle, right? It's equal to 2 sine u and times cosine u. How to get this formula? You just treat 2u as a u plus u, then you use the sum formula, right? You can get this result. And you also have cosine 2u. The same thing, cosine 2u. You treat u as a u plus u, then use the sum formula for the cosine. Then you will have cosine square minus sine square. So we know that cosine square, sine square is equal to 1 minus cosine square. So it becomes 2 cosine square minus 1. If you use cosine square equals 1 minus sine square, then you will have 1 minus 2 sine square. Okay. And tangent u to u, tangent to u, the same thing. Treat u as a u plus u, you can get this formula, 2 tangent u over 1 minus tangent square of u. This is called the double angle formula. The next one, which is the power reduction formula. Power reduction formula. So it says sine square, you can reduce the power sine square to sine, but you will need to double the angle. Sine square equals, you can actually solve this one, right? Solve this one for sine square. Sine square is equal to, then you can get this formula, cosine 2u over 2, right? So you can see we reduce the power from 2 to 1, but actually you double the angle, right? Cosine square u. So you can solve this equation for cosine square, right? So cosine square is equal to 1 plus cosine of 2u over 2. Okay, then you take the division, you will get tangent square, okay? Take the ratio, sine square over cosine square, so then you will have 1 minus cosine of 2u over 1 plus cosine of 2u. So this is called the power reduction formula. Then we have half angle formula. Half angle formula means this angle is the half of u. Okay, so now we will use this one. The same thing. You treat this u as u over 2. So it becomes 2u becomes u, right? Since it's squares, then you can have plus or minus square root 1 minus cosine u over 2, right? So it could be positive, could be negative, depending on the choice of this u over 2, which quadrant it belongs to, right? If it's in the first and second quadrant for u over 2, then sign would be positive, otherwise would be negative. Cosine of u over 2, which is, so you just replace this u with u over 2 and then u with u over 2, so it becomes u here, here's u over 2, then take the square root, the same thing. It depends on the choice of u over 2. If it belongs to the first and the fourth quadrant for u over 2, it would be positive. In the second and third quadrant, for u over 2, it would be negative, right? Then tangent to u. So you take the division, you will have this kind of things and simplify. You will have, it's 1 minus cosine u over sine u. Or it could be sine u over 1 plus cosine u. Okay. So this is the half angle formula. So now let's solve some problems using these formulas. We want to solve this trigonometric function. 2 cosine x sine 2x equals 0. Okay, so the first thing, we cannot factorize it because here 2x, you cannot just take 2 outside, okay? This 2x is inside the input, okay? And remember, the sine is just a name of the function, right? So you cannot take this 2 out. But we have the double angle formula, which is sine 2u equals 2 times sine u cosine u, so it can be written as, this is still 2 cosine x, but this is the 2 cosine x times sine x, right? Equals 0. So we can factorize it. So it's 2 cosine x times 1 plus sine x, right? Equals 0. So you have two solutions, okay? Cosine x equals 0 or 1 plus sine x equals 0, right? If cosine x equals 0, which angle? We need to find two angles for cosine sine, right? We need to find two angles in one period. So here x could be equal to what? 0 is pi over 2, right? Pi over 2 equals 0, cosine, plus 2 pi n, or 3 pi over 2 plus 2 pi n, right? Okay, but we notice that actually since pi over 2 and 3 pi over 2 are on the same line, right? The y-axis. So one angle is just add a pi, then you can change to another angle, right? So in other words, if we add a pi on this angle, then you will get this one. So actually we can combine these two. Okay, so x could be equal to pi over 2 plus pi times n, right? Pi times n. So this is the one solution for this part. And this part is sine x equals -1. Where sine x equals -1, x equals, we only have one angle, right? Equals x. So x equals what in one period? Which one? It's 3 pi over 2. Right? 3 pi over 2, then plus 2 pi times n. Right? And so now let's look at these two, right? But actually, this one, including this one, right? Including this one. And this end is different from this end, okay? These are two different ends. But actually, this one including this one. So in other words, so your solution would be x equals pi over 2 plus pi times n, where n equals 0, plus minus 1, plus minus 2, and so on. The reason is this angle, it has the terminal side on the y-axis, positive or negative, right? Negative y-axis. And this one is just the negative part of the y-axis. So actually this one includes this one, okay? So you can combine together to get this solution. Let's look at this example. Cosine theta equals 5 over 13. And where theta is between 3 pi over 2 to 2 pi. Okay, we need to find sine 2 theta, cosine 2 theta, right? And tangent 2 theta. Okay, so we know that sine 2 theta is equal to 2 sine theta times cosine theta, right? This is the double angle formula. And cosine 2 theta equals 2 cosine square theta, then minus 1, right? So here you just plug in this one, you can get your answer directly, right? So this one, you just save your time. You just use your calculator, you can do this calculation quite quickly, right? Plugging 5 over 13. And 5, it becomes 2 times 5 over 13 squared, then minus 1, right? And the tangent to theta, okay, tangent to theta equals 2 tangent theta, 1 minus tangent square. So in other words, we need to know what is tangent theta, right? Okay, so the condition is cosine theta equals 5 over 13, and theta is in the fourth quadrant, right? Greater than or equal to the 3 pi over 2 and less than 2 pi. So in the fourth quadrant. So the terminal side would be here, right? The theta, the terminal side would be here. So cosine theta equals 5 over 13. So that means there is a point, right? The distance is 13. And the x-coordinate, remember that cosine theta equals what? Equals x over r, right? So the x-coordinate is what? Is 5. So what about the y-coordinate? So we can use this Pythagoras theorem, right? This is 5. This side is 5 because x-coordinate is 5. So the length is 5. So you're using the 13 square minus 5 square, so it's actually equal to 12. Take the square root, it's equal to 12. However, this point is on the negative side, negative part of the y-axis, so it's negative 12. The length is 12, but the coordinate is negative 12, right? Okay, so we can see that. So sine theta would be equal to what? Y over r, right? Y here, y is negative 12 over 13. So this is sine, so we know the cosine, and we know the sine, so this one has been done, right? Just plug in the numbers. And the tangent theta is y over x, so which is negative 12 over 5, right? So we know the tangent theta, so we have this one to be done, right? So you just plug in the numbers to calculate. Okay, so now let's look at this one. Sine 105 degrees. This is not a special angle, right? However, we know that sine 105 degrees, which is in the second quadrant, right? Because in the second quadrant, the greatest value is 180 degrees, so it should be the second quadrant, right? Second quadrant, so sine is positive. So we can use the half angle formula, right? 105 degrees, which is equal to positive square root 1 minus cosine 210 degrees, right? Over 2. So 210 degree actually is a kind of special angle because the reference angle is what? The reference angle is 30 degree, right? So it can be written as this is actually 1 minus, what's this? What's the 2? So it should have the values, ignore the plus or minus, the values, the absolute value should be equal to the cosine 30 degree, right? Cosine 30 degree. Cosine 30, but it's 210, which is in the third quadrant. Third quadrant cosine is negative, so we have negative sign here, right? So it becomes 1 plus cosine 30 degree. Then we plug in the numbers. Okay, then it becomes let's simplify. Okay. So now let's look at this example. 1 plus cosine square x is equal to 2 cosine square x over 2. Right? Okay, so now you will see that we want to, you cannot solve this one directly because here is x, here is 1/2 x, right? You cannot take 1/2 outside. Okay, but we have the formula to change 1/2 and 1/2 of x becomes 1, which is power reduction formula, right? Power reduction formula is here. So it's equal to, so here u is x over 2, so it's here 2u becomes x. Okay, so this one is 1 plus cosine of x, cosine square of x equals 2 times 1/2 1 plus cosine 2 times 1/2 x, right? 2u. Okay, so this one is cosine. So this is 2 and 2 cancel out. It becomes is equal to 1 plus cosine x. Right. Then we have this is 1 and 1 cancel out. So you have cosine square minus cosine x equals 0. So you have cosine x equals 0. Sorry, I should factorize it. Cosine x minus 1 equals 0, right? You factorize it. So you have cosine equals 0 or cosine equals 1. Then we solve the equation separately. For cosine equals 0, you have two values, right, to make the cosine to be 0. X equals pi over 2 plus 2 pi times n, or you have 3 pi over 2 plus 2 pi times n, right? Okay, we know, as I talked before, we can combine these two angles because they are on the same line. The difference is just the pi, so it's actually x can be written as pi over 2 plus pi times n, okay? So here n is equal to 0 plus minus 1 plus minus 2 and so on. So for this part, so x equals 1 and cosine x equals 1, which angle in the 1 period, which is, well, we can just pick the one angle, so it's 0, right? Cosine 0 equals 1. So it's 0 plus 2 pi times n. So x equals 2 pi n. Actually, we cannot combine these two. We cannot combine, so you have two solutions. X equals pi over 2 times pi times n, or x equals 2 pi times n. Okay, so this is your solution. So now let's look at more formulas. The first, the one we will talk about here is the product to sum formulas. So that tells you that sine alpha times sine beta. This is a product, right? We want to change it to be the sum of two trig functions, which is actually 1/2 times what? Cosine alpha minus beta minus cosine alpha plus beta. Okay. So cosine alpha times cosine beta. So it becomes 1/2 times cosine alpha minus beta plus cosine alpha plus beta. Right. Then you have sine alpha times cosine beta, which is 1/2 sine alpha plus beta plus sine alpha minus beta, right? And cosine alpha times sine beta, which is 1/2 times sine alpha plus beta minus sine alpha minus beta. So the proof is quite easy. You just using the sum of difference formula for the right side, then you can get to the left side, right? Then you have the sum to product formula. Product formula. So this is the sum of difference, right? Sum to, then we just solve, multiply by 2 on both sides, right? So we notice that this alpha is actually alpha minus beta plus alpha plus beta, then divided by 2, right? Would it be alpha? Beta would be actually alpha plus beta minus alpha minus beta, then divided by 2, right? So it's just like reverse the formula for the product to sum. Then we can get the sum to product, which is sine alpha plus sine beta is equal to 2 sine alpha plus beta divided by 2 times cosine alpha minus beta divided by 2, right? So like this one, right? We multiply by 2. We multiply by 2, right? Then alpha plus beta becomes alpha, right? So here, this position becomes alpha, this position becomes beta, right? So this alpha becomes this alpha plus this beta, then divided by 2, right? Okay, similarly, you will get sine alpha minus sine beta. So you can see we can combine sine alpha plus sine beta and sine alpha minus sine beta. So, but you cannot say, okay, it's equal to sine alpha minus beta directly. No, it should be equal to the 2 times the product of trig functions. So it becomes 2 cosine alpha plus beta over 2, right, times sine alpha minus beta over 2. Cosine alpha plus cosine beta, which is equal to 2 cosine alpha plus beta over 2 times cosine alpha minus beta over 2. Cosine alpha minus cosine beta, which is equal to negative 2 times sine alpha plus beta over 2 times sine alpha minus beta over 2. Okay, so now we have the sum of two product formula. So now let's look at examples, how to use these kind of formulas. So we have sine 5x plus sine 3x equals 0. So we cannot say, okay, it's equal to sine 8x because you cannot combine directly. However, we have used this formula, right? It becomes 2 sine, this is alpha is 5x plus beta 3x over 2, right? Times, right, here is cosine, so cosine 5x minus 3x divided by 2 equals 0. So you have 2 sine 4x equal times cosine x equals 0. Okay, so now let's look at this one. So it tells you that sine 4x should be equal to 0 or cosine x is equal to 0. So now let's look at these two trig equations separately. So 4x, so this tells you that 4x equals what? Equals 0 plus pi, 2 pi times n, or equals pi plus 2 pi times n, right? So actually we can combine these two angles because these two angles are on the same line, which is on the x-axis, right? The difference is just the pi, so the 4x can be written as what? Pi times, we can use, instead of using n, we can use other integers to represent. For example, we use k equals 0 plus minus 1 plus minus, or you can still use n, but make sure this n is different above the previous two n's, okay? So this is x equals pi over 4 times k, so which is a multiple of pi over 4. So now let's look at cosine 0. Cosine 0, which is cosine x equals, so x equals what? Pi over 2 plus, this we have done several times, right? 2 pi times n. Or you have 3 pi over 2 plus 2 pi times n. So we know these two angles are on the same y-axis, right? So you can combine because the difference is pi. So it's actually 2 pi, pi over 2 plus pi, multiple of pi. We can use k instead of n. Of course, you can still use n. So this k is still from 0, plus minus 1, and plus minus 2, and so on. Okay, so we notice that this is this one will cover this solution, right? We cover this solution because if k equals 2, it becomes pi over 2, right? Okay, so you can see all the angles here. No matter which angle you choose, right, you can always find some angles here, some k for this angle, right? So in other words, our solution is pi over 4 times k. Here k equals 0 plus minus 1, plus minus 2, and so on. So this is your solution. So now let's look at this example. Cosine 195 degree plus cosine 105 degree. Okay, so this is the sum of two cosines. So we actually can use this formula, right? This formula, it says it's equal to 2 times cosine 195 degree plus 105 degree divided by 2. This is cosine 195 degree minus 105 degree divided by 2. So this is equal to cosine. So this is 300 degrees. So it's divided by 2, 150 degree. Wow, this is a special angle, right? Times cosine. This is a 45 degree. Again, this is special angle. And we know that, so this one, the reference angle is 30 degrees. So it should be equal to cosine 30 degrees, positive or negative, because 150 in the second quadrant, so cosine is negative, so we have negative here. Times cosine 45, we know it's equal to square root 2 over 2, right? So it's equal to 2 times negative square root 3 over 2 times square root 2 over 2. Then you will have negative square root 6 over 2. Okay. So next question. Sine x plus y times cosine x minus y. Okay, we want to simplify. Okay, so we can use this formula, right? Sine times cosine, which is this formula. So which is equal to 1/2 times what? Sine alpha plus beta, so it becomes x plus y plus x minus y, right? Then plus sine x plus y, alpha minus beta, minus x minus y. So this one is equal to sine 2x plus, this is sine 2y. Okay, that's it. Of course, if you want to continue to simplify, you can write using the double angle formula, right? But it's okay as for me. It depends on the problem, right? Or you can continue to write it as I use another color. No. We can use another color to continue to write. It's equal to 1/2 times sine x 2 times sine x cosine x, right? Plus, this is the 2 sine y cosine y, okay? Then you distribute 1/2 to each term, so it becomes sine x times cosine x plus sine y times cosine y. Okay.